A VOR is a radio station that transmits radio navigation signals in the very high frequency or VHF band. The station transmits radio signals called radials in every direction away from the station. Pilots use 360 radials, one for each degree in a circle, to determine position. If the equipment in the airplane says the airplane is on the 360 degree radial, then the airplane is north of the VOR. An airplane on the 90 radial is east, while one on the 180 degree radial is due south of the station. Since pilots rely on the compass for directional guidance, the radials transmitted by VORs are aligned with magnetic north. Before using a VOR for navigation, it must be tuned and identified. Tuning in the VOR is a simple matter of selecting the proper frequency on the receiver. Next, configure the airplane's audio system so that you can monitor the audible Morse code identifier, which is broadcast by the VOR station. Each VOR has a unique 3-letter identifier. By hearing the Morse code for this 3-letter identifier, you have positively identified that the signal on your display is being received from the intended VOR. To find your location from a VOR, turn the Omni-Bearing Selector knob, or OBS knob, on the VOR receiver display until the needle centers and the To From flag indicates From. Once the needle is centered, your magnetic bearing or radial from the VOR is shown on the top of the display. For example, if the reading was 135, this tells you the airplane is located over the 135 radial. In other words, the airplane is southeast of the VOR. One thing that can be very confusing when learning VOR navigation is that the radial you are on has nothing to do with your heading. You could be on a 135 radial and headed north, south, or any direction. To find the direction to a VOR, rotate the OBS until the needle is centered with a To indication. The number shown on the top of the display is the bearing from your airplane to the VOR. This is exactly the opposite of the direction from the station to the airplane. Therefore, your bearing or radial from the station is also shown on the bottom of the display. To fly directly to a VOR, with the needle centered with a To indication, turn the aircraft to the bearing on the top of the VOR receiver display. Since the VOR is displaying the direction to the station and your airplane is flying that heading, you will be heading directly to the VOR. However, the airplane will drift with the wind unless a crosswind correction is applied. To correct for the wind, maintain your heading and observe the movement of the needle, which is referred to as the Course Deviation Indicator, or CDI. If the needle moves right or left, it indicates the need to move the airplane right or left to stay on course to the station. This is another confusing concept of VOR navigation. The needle is not telling you to turn right or left, it's telling you to move the entire airplane right or left. Of course, in order to do this, you will have to turn the airplane. However, your goal is to adjust the heading with the purpose of moving the airplane laterally. Remember, the needle is giving you position information, which has nothing to do with your airplane's heading. For example, if you were directly south of a VOR on its 180 degree radial, then centering the needle with a To indication would result in 360 being shown, since the VOR is directly north of the airplane. Turning the airplane to a 360 heading will get us heading towards the station. While maintaining a 360 degree heading, observe the movement of the CDI. Let's say the CDI begins to move to the right. In this case, the instrument is telling us that we are drifting to the left with the wind whenever we maintain a 360 heading. At this point, we must choose a new heading to counteract the airplane drifting to the left. We'll turn right and establish the airplane on a 015 heading. Maintaining this new heading, observe the movement of the CDI. Let's say it continues to move right. We can gather that a 15 degree heading is not enough to counteract the wind. A greater correction is required, so let's turn further right to a heading of 030. While maintaining a 030 degree heading, the needle begins to move back towards the center of the display. This means a 030 heading more than counteracts the wind, and we are returning to our desired course. Maintain our new heading until the CDI is centered. Once the needle is centered, we make a guess as to what heading will perfectly counteract the wind. We know from our experience so far that a 030 heading more than counteracts the wind, but a 15 heading fails to counteract the wind. So we should pick a heading between these two. We decide to try a 020 heading. After maintaining that 020 heading for a few minutes, the CDI needle is still centered. This process of determining the proper heading for wind correction is known as bracketing, since you progressively narrow the range of headings the desired wind correction heading lies within. To fly directly away from a VOR, with the needle centered with a from indication, turn the airplane to the bearing shown at the top of the VOR receiver display. This will result in the airplane flying directly away from the station. This is because you have turned the airplane to a heading that is the same as the direction your airplane is from the station. Track the radial away from the station using the same bracketing technique as when flying to the station. If you attempt to track a radial from the station with a to flag being displayed, the needle will work in reverse. The pilot would need to fly away from the needle, not towards it, in order to keep it centered. This is also true if flying to the station with a from flag. To alleviate this reverse sensing, make sure the to from flag displays the correct indication. If it does not, rotate the OBS until the desired flag appears. The to from flag may also display an off indication. The off indication is shown when neither a to from indication is appropriate for the OBS selection. Such as a selection that would take the airplane neither to or from the station. It is also displayed when directly over or very close to the navigational aid. If none of these conditions exist, then an off flag could indicate a loss of signal from the nav aid. Since the radials a VOR transmits all originate at the VOR station itself, the distance between radials increases the further the airplane is from the station. This means that the needle is slower to respond at greater distances from the VOR, since the airplane must move a greater distance to move from one radial to the next. As the airplane gets closer and closer to the station, the needle will become more and more sensitive, making it more and more difficult to keep centered. When overflying a VOR, the needle will become more and more sensitive until, when very close to the nav aid, the needle will likely swing all the way to the left or right. At these close distances, simply remain on your heading. The to from flag will change to an off indication as you pass the station. Once on the other side, the from flag will appear. As you track outbound from the station, the needle will become less and less sensitive with your increasing distance from the VOR. Oftentimes, it is desirable to track a specific radial. To do so, dial the radial you desire to track using the OBS. Turn the airplane to a heading that is the same as the course you selected with the OBS. The airplane is now roughly paralleling your desired course. Next, select a new heading which will intercept the desired course. If the needle is not deflected to full scale, only a small heading change may be required, such as 15 or 30 degrees in the direction of the needle deflection. If the needle is deflected full scale, a greater intercept heading may be required. You may choose to use the OBS knob to center the needle with a from indication to see which radial you're currently on, then return the OBS to the desired course. Choose an intercept heading in the direction of the needle between 30 and 90 degrees left or right of your current heading. When the needle begins to center, turn to the desired course. Track the desired radial using the bracketing technique to correct for wind drift. DME, or distance measuring equipment, consists of stations on the ground and equipment in the airplane. DME operates in the ultra-high frequency, or UHF, band of frequencies. When a VOR is fitted with DME equipment, it is referred to as a VOR DME. Each VHF VOR frequency is paired with a specific UHF DME frequency. This means the pilot only needs to use the VOR frequency and does not need to be concerned with the DME's UHF frequency. Before using DME, identify the DME to be used by listening for its Morse code identifier. DME equipment does not have its own unique identifier. Instead, it uses the identifier of the VOR to which it is attached. The DME will transmit its parent VOR's Morse code identifier once every 30 seconds. DME operates by measuring the time it takes for a radio signal to be relayed from the airplane to the ground-based DME equipment and back. The result is displayed in nautical miles to the pilot. A TACAN is a ground-based navigational aid used for tactical air navigation by military aircraft. Its operation is not very similar to a VOR DME, and the azimuth transmitted from a TACAN can only be received by military aircraft. Civilian aircraft, however, can receive the DME portion of a TACAN. It's common for a TACAN transmitter to be fitted with equipment which allows it to be used as a VOR or a TACAN. These joint civil-military navigational aids are called VORTACs. From the civilian user perspective, a VORTAC is identical in use and function to a VOR DME. A VOR test facility broadcasts test signals to permit pilots to check the accuracy of their aircraft's VOR receiver. VOT locations and frequencies are listed in the airport facilities directory. To use a VOT, simply tune its frequency. The VOT does not broadcast a signal usable for navigation. Instead, it broadcasts a test signal, which tells your aircraft it is directly north of the VOT station regardless of its actual position. This means your onboard VOR will always indicate 0 degrees from or 180 degrees to when the CDI is centered.